So today is our group presentation, and these are the members of our group. So our content for this presentation is introduction, material selection, manufacturing process, assumptions, calculation, flexing simulation, and also conclusion. So the introduction is, flange is a device that connects pipes to form a pipeline network. The objectives are to select the best materials for the flange, to select and describe analysis in detail the manufacturing process for the flange, to propose the manufacturing process flow, to produce the flange including the inspection and quality control, to establish the number of equipment needed to produce the required demand based on the estimated process times for each equipment, to observe the real model system operating using the flexing, and finally the problem statement is to produce 50,000 units per month. So next, for material selection, I would like to pass to Fauzan.
Come to material selection. For the material selection, we have jot down list down into two materials, which is stainless steel 304 and also aluminium 6061. So out of many materials that we have in the world, we choose stainless steel over aluminium because of a few properties. First is because the corrosion resistance. For the stainless steels, it is better corrosion resistance rather than aluminium 6061. And for the mechanical strength, we choose stainless steel because it has high strength, but for the aluminium, it has only medium strength, because we know that we are using the flange for the pipeline, so we are going to use the high strength for the mechanical strength. And for the machinability, both are good, but in terms of forgeability, stainless steel can be forged rather than aluminium 6061, because we know aluminium, usually they don't forge the aluminium materials, they shape it, but in terms of the sustainable, stainless steel is better because it will maintain the shape with high force or any other force that come from the outside. And for the heat treatment, alloy, which is or we call aluminium, it's heat treatable alloy, so it can be changed into shape, it can be changed into the chemical reaction or something by using the heat. For the stainless steel, heat treatment is not the easiest way for the stainless steel to change the shape or the formability. And lastly, for the cost, we start to use stainless steel instead of aluminium, even though it has medium cost rather than low cost for aluminium, because we want our flange to be sustained. We want our flange to can be used frequently, and that's it. That's why we choose stainless steel 304. Thank you.
Okay, we will proceed with the manufacturing press for flange. So this is the process that we need to follow for flange manufacturing. It consists of cutting, heating, inspection, fogging, inspection, heat treatment, again inspection, machining, inspection, drilling, and the final one is the final inspection. Okay, for the first process, which is cutting, it consists of two methods, which is cutting the round plate and also cutting the stripes. It starts with cutting the stripes from the middle plate, which is then rolled into the round shape. Next, we will cut the stripe into a round plate with the spec that was given in the procedure based on the inner diameter, outer diameter, and also the thickness. Next, we proceed with heating process. The heating process means it will soften the metal before the fogging process started. That's all about the heating, and we will go for the inspection based on what we have done in heating and cutting. Proceed with the fogging process. For the fogging process, we will use the cold fogging method, which means the flange will be fogged below the recrystallization temperature. So the step involved in the cold fogging start with the metal is placed into a die that is attached to an anvil, and next the metal is then hit by a descending hammer and force it into the die. Okay, after the fogging process, and again we will inspect the product that we have done, and we will proceed with the heat treatment. So the material that we have choose for this flange is stainless steel 304, because stainless steel 304 cannot be hardened by heat treatment in the general. It can only undergo annealing or solution treatment. That's why we choose stainless steel 304. And the solution treatment or annealing can be done by rapid cooling after heating to 1010 to 1120 degrees Celsius. And what does it mean by annealing? Annealing is heat to 900 degrees Celsius and furnace cool for mass strength and hardness. And also the function of heat treatment is to reduce the residual stress in the flange and optimize the corrosion resistance. And again, we will inspect our product and proceed with the machining. Machining is actually the flange facing, which we will do the surface finishing to ensure the quality of the surface. After machining, and we will do the final inspection, and we will proceed with drilling process. The function for the drilling process is to make the hole for the flange, and that's only the main thing in the drilling. And now we will go to the last step, which is final inspection. The quality of the flange is checked at various stages for any surface defects, and we will also do the quality control process of the flange at the end of the process. I think that's all for the flange manufacturing process.
Good morning, my name is Annie. I'll be presenting on assumptions for the calculation. Here are the listed assumptions. The number of working hours, 28 days per month. The number of shifts, 2 shifts per day. Number of hours per shift is 8 hours per shift. Number of equipment is 11 machines. The cycle time and setup time is also assumed for each of the process. The scrap rate is 1%, which is equivalent to 0.01. And the number of batches is 28 batches. Okay, for the first part of the calculation, we have to calculate on the estimated plant capacity. The plant capacity is the amount that it can fit the demand, which is for 50,000. Based on the calculation, we got about 50,758.4 flanges per month, which is enough to for the plant capacity. Thank you.
Good morning, my name is Nur Haskinsa, and today I'm going to proceed with the estimated cycle time for each process. So basically for the cycle time for each process we'll assume, and in order to get the rate of production, so these are the formula that we use in order to get the rate of production, and these are the cycle time that we assume for the to be used inside the formula. So next, for the number of equipment, in order to get these results, we use the formula here, and the result in order to get 50,000 flange per month, we have to use 6 number of machine for the in the plant capacity in the plant.
Hi, my name is Dayang, and I will be presenting for the FlexSim simulation and conclude the presentation for today. So basically, this is the model for the simulation, and it's been created based on the calculation previously, and based on the picture, there is 6 stages of machining and 5 stages of inspection. Inspection is needed to ensure the product quality. And we use robot as the transporter because our product is flange and it is heavy and big. Next, so that is the data. This is the data that been collect from the FlexSim simulation. That is step 5. Basically, step 5 shows the percentage of the equipment in each stage of production, and this is throughput command per hour and input versus time. So based on this, we can see that per shift is 8 hours, which is from 8 to 4, and the output for per shift is 1030. So we have 2 shifts per day and 28 days per month, which is total 57,680 flange per month, and it's different from the calculation that we calculate previously. Maybe it's because of the error in cycle time estimation and setup time. So to improve the utilization, we can increase the number of demand as the model can give extra 7,000 plus. And next, so in calculation, our flange use stainless steel 304, and there is 6 process on manufacturing, which is cutting, heating, fogging, heat treatment, machining, and drilling. And not to forget, there is final inspection. And to produce 50,000 flange, based on the calculation, 1 machine for each process, which is in total 6 machines. And using FlexSim simulation, we can demonstrate it, and there is extra production that been produced. So next, so this is the reference that been used. So that's all from us. Thank you.